Next, let's move on to the next problem. Question is this. It says that maximum frequency of a band limited signal x of t is 5 kilohertz. Then we have to find out the maximum frequency of this new signal, which is x of t cos 2000 pi t. So what is given about x of t here? X of t is a band limited with 5 kilohertz, means this fellow's bandwidth should be how much? 5 kilohertz. So let us try to draw the corresponding Fourier transform. I will draw it nicely. Okay, so how does that look? The corresponding Fourier transform, sorry, yeah, so let me draw it neatly. Yes. Okay, so we don't know the shape, so let's assume this is the shape of the Fourier transform and this is in omega domain, and hence this limit should be how much here? Minus 2 pi into 5 kilohertz, so that should be equal to minus 10,000 pi. Okay, and this fellow should be 10,000 pi. So highest maximum frequency is 5 kilohertz, that is in hertz. So if you convert into omega domain, that would be 10,000 pi. Now question is, we have to find out the maximum frequency of new signal, which is x of t cos 2000 pi t. So what will happen to the Fourier transform here? The Fourier transform should shift to the left and right by how many units? 2000 pi. So if you shift to the right by 2000 pi, so what will happen? The spectrum will look like this. So this should be 12,000 pi. And then you have to shift to the left by 2000. So the plot will look like this. Okay, so this is minus 12,000 pi. Okay, so this would be the Fourier transform of x of t cos 2000 pi t, and this, let's say this is x of j omega. So Fourier transform should shift to the right and left by 2000 pi. So overall plot, how does it look at? We have to add these two fellows. So overall plot will exist from where to where? So it will have some shape, something like this. Okay, so overall plot will look like this of the Fourier transform. Okay, so this should be minus 12,000 pi and this will be 12,000 pi. So what is the highest positive frequency here? In radians per second is 12,000. Okay, so highest frequency is equal to, we will say 12,000 pi radians per second, or if you want in hertz, that should be equal to 6 kilohertz. So this is 6000 hertz, or we will say 6 kilohertz. So what is the question? We have to find out the maximum frequency of x of t cos 2000 pi t in kilohertz. So what should be the answer? It should be 6. Okay,